All right, we're going on now to topic 3 of chapter 1, which is fractions and mixed numbers. Now, one of the words you're going to run into every once in a while is this word quotient. Now, the quotient of two numbers is written as a fraction. Often a synonym for fraction is a ratio. And often as another synonym of fractions are the rational numbers, one of the sets we spoke of earlier. Now, when we think of a quotient between 2 and 9, it would be written in this form, where the upper part is the numerator and the bottom part is the denominator. And you might have a pretty good handle on this already and know it from your work in elementary school, high school. They've talked about this a lot. But I always liked the story of Yogi Berra, who was a catcher for the Brooklyn Dodgers years ago. And then later, when they went to California, he played for them. And then he is still alive, does broadcasting for them. But he tells this story that every Friday evening, he would go into Pepe's pizza parlor and have a pizza, and they would cut it up into 8 pieces. But this Friday night he went and he said to Pepe, he said, "You know, tonight I'm not too hungry. Only cut it up into 4 pieces." So as you think about that, and think about it some more, you might say, hey, wait a minute. He's actually getting the same amount of pizza. Yes, and that's where fractions come in. One of something isn't always one of something. Now, this is the whole pizza, but if you cut it up into 8 pieces, you're getting 1 out of 8. If you're cutting it up into 4 pieces, you're getting 1 out of 4. So you're not getting one of these is not equal to one of those. Why not? Because the denominators are different. And that's why we say in dealing with later addition and subtraction of fractions, in order for it to be a sort of an equal thing, our denominators need to be the same. So as we look at this little example of a circle that I have here, this is the whole. This is 1. But if I cut the whole into 2 parts, my 1 is now 1 out of 2. If I cut it into 4 parts, I have 1 part would be 1 out of 4. Again, cutting it into more parts, that's 1 out of 8. So our denominator in our ratio challenge here, or comparison, is what are the equal units in what you are dealing with. Here you're dealing with 9 equal units, and you're going to shade 2 of them. Okay? So we might have the fractions. Let me just use this as an example. This was the original 1/2. When I cut it into fourths, that became 2/4. And then when I cut it into eighths, that became 4/8. So we say that 1/2 and 2/4 and 4/8 are all equivalent. But the point is, how did we get there? Well, what did we have to do to multiply 1/2 so it became 2/4? Well, we can multiply any number by 1 and it stays the same. But if our 1 is in the form of 2/2, remember 2/2 is 1, we now go 1 times 2, we get 2, 2 times 2, we get 4. If we multiply this by 1 in the form of 2/2, that gives us 4/8. So the general rule for getting equivalent fractions is to multiply a fraction by 1, but that 1 is in the form of some number that gets the desired denominator. And of course, we'll be practicing that and see how it works. Okay, going on now to another key term, prime numbers. Well, what is a prime number? By definition, a prime number is a number whose factors are only 1 and itself. So some of the prime numbers would be 2, 3, 5, 7, 11, 13, 17, 19, and there's more, of course. But these are prime numbers. That is, the only factors of the number is 1 and itself. And it can't be 1 and 1. So 1 is not a prime number. We start off with 2. So, what would be the technique of developing what we call a prime number factorization? And the answer would be, take the number you're dealing with, and sometimes they use a tree. I like this technique, you can use a tree if you like. So I see that that's even, so I know I can take a 2 out of there. So 2 goes into 40 20 times. Then that's even. I know I can take a 2 out of that. That goes 10. 10 is even. I'll take a 2 out of that, and I get a 5. And now I have a series of prime numbers along the side, and the prime factorization of this would be 2 times 2 times 2 times 5. In fact, that's 8 times 5 is 40. All right, 63. Now, 63 is not prime, but if I use the rule of threes, the rule of threes state if you add up the digits, the 6 and the 3 get a 9, is that divisible by 3? And it is. So I know I can take a 3 out of there. And that'll be 21. And if I add 21 up, that's a 3. That would be divisible by 3 as well. So our prime factorization of 63 is 3 times 3 times 7. Now, there's a few extras, and you're going to be doing some, but I thought I'd just do another one for you and throw it in. 240. It's even, but it also adds up to 6. So I could take a 3 out, but since it's even, I'm going to start with a 2. So this is 1, 2, 0. That'll be 60, 30, 15, and there's my prime factorizations. Remember, on the outside, you want to get a prime number. So here I know I have 9 times 7, but if I took a 9 out, 9's not prime. So that's why I use this method here. Okay, that's a technique you're going to have to work with, and you'll need to know for continuing work with fractions. Okay, we're going on to example 2, where they're asking us to simplify to lowest terms. And again, when you think of a number and you want to simplify, you're thinking prime numbers a little bit in the background, and you're saying, well, what are the factors of 42? Well, when I see 42, I think 6 times 7. And when I see 49, I think 7 times 7. Now, when I look at that, do I see any 1s in there? Well, 7 over 7 is 1. So in a sense, I can factor that out, or cancel out, or simplify. So 42 49ths becomes 6 over 7. Now, here I see a prime number, 11. Is 11 a factor of 27? And the answer is no. So 11 27ths, this is in lowest terms already. You can't do anything with that. Now, for letter C, as we look at this, couple of things. You want to think of maybe prime factorization. Well, I know I can take a 2 out of there, and a 2 out of there, and that leaves a 10 here, and a 44 there. And again, I'm not writing this out, but I can take a 2 out of there, out of that 44, and get a 22. And then I can take a 2 out of the 10, and I get 2 and a 5. So I know I could take another 2 out of here, but there's no more 2's down below to take out. So keep in mind, this is a 1, this is a 1, and I'm left then with 22 fifths. Now I don't know if the book wants it that way. Let me take a look here. Yes. Now, whenever the numerator, the number on top, is larger than the bottom, the denominator, this is called an improper fraction. All right. An improper fraction. Now, if we, and this is something we're going to have here shortly, if we change that, how many times will 5 go into the numerator? And it goes into there 4 times, as 20 over 5. That's a 4. And then we're left with 2 fifths. So 20 fifths plus 2 fifths is 22 over 5. And then this can be written in 4 and 2 fifths. This is called a mixed number. And again, we're going to be using some of these terms. I may be jumping a little ahead. All right, we're now going on to multiplying and dividing fractions. First we'll look at multiplying. that here's your fraction a over b times c over d. Now we look through there, we don't see any common factors, so the product of multiplying fractions is just multiplying the numerators, AC, multiplying the denominators, BD. Now when we go to practice this, we look to see first if we can do some simplifying. And the technique that I would use, you could use another technique if it's familiar to you, is I see a 5 here, and I could factor out a 5 there. So 5 goes into 5 once, 5 goes into 15 3 times. So nothing else cancels. So 2 times 1 is 2. 3 times 13 is 39. Now, by the way, if you've done the canceling up in here, when you get this answer, there'll be nothing else to cancel out. If you didn't do the canceling here, then you would have to simplify this answer. All right, this is just another one that we had. Again, 3 goes into there once, 3 goes into there 3 times, and we end up with 7/24. This is multiplying fractions. As we do division of fractions now, the example would look like this: A divided by B divided by C over D. Or this fraction divided by this fraction. Now here's the key to that. The basic rule is we're going to convert all division of fractions to multiplication of fractions. We do that by changing the division sign to multiplication, and then the second term we flip it. That is, take the reciprocal. The D goes on top, the C on the bottom, and then we multiply that. So actually, all division of fractions become multiplication of fractions by converting from division to multiplication, taking the reciprocal. So let's do that here. This is going to become 4/5 times 16/5. This is going to become 7/10 times, now this is, every number's over 1, so 1/14. And then this is going to be 3/8, change the division, take the reciprocal of that, 10/3. Now notice here, there's no cross multiplication that you can do. So we just go 4 times 16 is 64. 5 times 5 is 25. Now here we notice 7 will go into there once, into 14 twice, so this becomes 1/20. Here the 3's cancel out, and take a 2 out of there, get a 4, 5, so this becomes 5/4. The key is when you are dividing fractions, you change it from a division to a multiplication, take the reciprocal, and then cancel wherever you can. As we get to our next section here, adding and subtracting fractions, this is where it is so important to have common denominators when we are adding and subtracting fractions. So if they are already the same denominators, it's actually sort of an easy thing. We put our numerators, 2 plus 4 over our common denominator. 3 plus 2, 9 minus 2, 5 minus 1. So if they are already the same denominator, we just actually do the action of our numerator, and then this will become 6 over 7. And we don't see any common factors that we could simplify. This is going to become 5 over 10, but here we see we could take a 5 out of there and a 5 out of there to simplify, and this eventually becomes 1/2. So again, part of the answer is you need to simplify. Now notice here we get 9 minus 2 is 7 over 7, and that simplifies to just 1. And then here we get 4 over 3. Didn't make that 3 very well, but I guess you can see it. And the key is if they are already common denominators, we just do the action, the operation in the numerators, put it over the common denominator, simplify if you can. In this next part, we're looking for a procedure to convert, let's say, 2/5 to something with a denominator of 20. Now remember, we are allowed to multiply anything by 1, and that keeps it the same. But now we're going to choose a 1 in the form of something that will make our denominator a 20. So how about 4 over 4? 4 over 4 is 1, but now it makes the denominator a 20 here, and our numerator an 8. So when they ask, convert this fraction to a fraction with a denominator of 20, what do you multiply the denominator by to make it a 20? And then you multiply the numerator by that same number, in a sense, 1 over 1, 4 over 4, equivalent to 1. And I just did an extra one here. What are we going to multiply 4 by to get a 28? And that will be a 7. So we multiply the numerator by 7 as well, and that then gives us a 21. Now, the fractions look different, but they are equivalent. That is, we're cutting that pizza pie up into a number of equal slices, so that when we're dealing with items of the numerator to add or subtract, they have equal value. They're the same size units. And you're not adding 1/4 and 1/8. You're getting a totally different things. Those ones are not equivalent. Now we get to the test of the pudding, so to speak. Here we are adding fractions, but our denominators are not the same. They are unlike denominators. So what we need to do is to find the least common denominator of these fractions. Well, one easy way, of course, is just to multiply the two numbers. And this would give us a 20. Now here, if we multiplied the numbers, we'd get a very high number, and that would be too big. So we think, what's the factorization of the 6? 2 times 3. The factorization of the 12, that would be 2 times 2 times 3. So we have a 2 times 3 and a 2 times 3. So actually with a 6 and a 12, 12 is your common denominator. Now if you had chosen 24, 12 would go into 24, 6 goes into 24. But again, you want to try to keep it small. That way at the end you don't have to cancel. Simplify. Again, part of this is a little bit of judgment. You're an artisan, kind of figuring out things. Here's a 2, 22, 11. In fact, 2 times 11 is 22. So my common denominator is 22. So now what we have to do is convert each of these fractions to a denominator of 20 and 12 and 22. So here this is going to be 5 times 4. 4 over 4 is 1. This is going to be 5 over 5. And this one only needs to be times 2. 2 over 2 is 1. That'll make this denominator a 12. Here we're going to multiply this by an 11. This doesn't need to change. And this one by 2. Again, all these items that I have in red are something over something that equals 1. But in doing that calculation, it allows us to get equal parts in our denominators, so that our numerators now reflect a true value, so to speak. So this is going to be 8 plus 5. This is going to be 2 times 19 is 38 minus 23. And this is going to be 11 plus 17 minus 4. Well, this one's easy. This is going to be 13/20, and I don't have to cancel out anything there. This is going to be, I believe, 15/12. But now I see it, there's a common 3 that I can cancel out. 3 out of there is 5. 3 out of there is 4. And then here, when I add these two together, I get 28 minus 4 is 24 over 22, which would become 12 over 11 after I cancel the 2 out from each one of those. All right, moving on, and we're on page 21, although you may not see it. We are going to be performing operations on mixed numbers. Now remember, we said mixed numbers were numbers that had a fraction and a whole number. So the key to this, and since this is division, we're going to eventually convert it to multiplication. But in order to do that, we have to get it into its fraction form. So the first thing we must do is convert this mixed number into an improper fraction. And we do so by multiplying the denominator of the fraction times the whole number. 8 times 2 is 16, plus 1 is 17 over 8. Divided by 3 times 1 is 3, 5/3. Now we are going to convert it to multiplication. Take the reciprocal of this, which is then 3/5, and now we can do our multiplication. Notice there's no common factor anywhere. So we go 3 times 7 is 21. How about 51 there? Over 40. And you may leave it in that form, unless, let's see what they're asking here. They want us to practice changing it back to a mixed number. So then we divide the 40 into the 51, and it goes once, and there's 11 left over. So that would be our final answer. On most tests, they'll say leave it as an improper fraction or a mixed number, and they'll tell you what they want, and then that'll determine how far you have to go. Now in example 9, they're asking us to do the operation of subtraction, and part of this is what strategy do you use? Well, I would suggest a strategy in which you line them up like so. And then what you need to do is manipulate it a little bit so that you get common denominators. So here, our common denominator will be a 6. So I'm just going to change this to 2, 6. Remember, this originally was a 1/3. Multiply that by 2, multiply that by 2. But now I really can't subtract that 2, 6 from 1, 6. It's too small. So in the old days, what we did is we borrowed. I'm going to borrow a 1 in the form here of 6 over 6. That's a 1, that this now becomes a 49. But now this is 7, 6 minus 2, 6. And I can do that now. That's going to become 5, 6. And I can subtract 38 from 49 and get an 11. And there's my answer. And that's the strategy I would suggest you do. And again, you're going to practice, try different things. Good luck on your practice and quiz me of section 1.3. We'll be doing 1.4 next.